Alright, I have my quiz questions. Those, my muscle diagram, my muscle contraction diagram, and then my grid that I made. So the first question is, pick 5 major muscles that were discussed in lecture and describe their orientation to another major muscle using correct anatomical terminology. You're free to use a printed diagram to assist you in answering the question. So my 5 muscles were the deltoid, the platysmus, the pectoralis major, the biceps brachii, and the external oblique. So the deltoid would be like triangular muscles, wraps around to the shoulder and connects to the clavicle, scapula, and the humerus. Your platysmus is fascia that covers the clavicle across. Your pectoralis major is here, and it pulls towards the body, pulls your arm towards your body. And then I picked the biceps brachii. It makes to where your arm can move above your shoulder socket on your scapula. So it'll run up over your scapula to the back. And then your external oblique would be your diagonal muscles that help to tighten the abdomen. Number 2 was describe what conditions can lead to muscle fatigue. It'd be like age, anemia, infection, anxiety. Number 3 is explain how the skeletal system, muscular system, and nervous system are integrated by describing the relevance of neuromuscular junctions. So neuromuscular junctions are connections that go from the terminal end of your neuron to the muscle, and then from the site of action to the nerve, from the nerve to the muscle. Number 4 is compare and contrast origin and insertion, as well as flexion and extension. Origin and insertion. Origin comes from not moving during contraction, and insertion comes from where the attachment site does move with muscle contraction. And then flexion and extension, the main difference is one is away from the body and one is towards the body, or towards the other bone, depending. Number 5, draw a diagram depicting what happens during a muscle contraction. So here's my diagram. And then I wrote them out. That's a lot to know. Stage number 1, your nerve impulse arrives at an axon terminal and triggers release of acetylcholine. Number 2, acetylcholine diffuses across the cleft and it binds to its receptors in the motorhead plate and triggers a muscle action potential. Number 3 is acetylcholine is a synaptic cleft and it destroys, or acetylcholine E is a synaptic cleft and it destroys acetylcholine, so another muscle action potential does not arise until more acetylcholine is released. Number 4, stage number 4, muscle action potential traveling along T-tubules opens Ca2 plus release channels in the sarcoplasmic reticulum, which allows calcium ions to flood into the sarcoplasm. Number 5 is Ca2 plus binds to troponin on the thin filament, exposing the binding site for myosin. Number 6 is contraction, the power stroke of ATP. Myosin heads bind to actin, swivel, and release. Thin filaments are pulled towards center for sarcomere. Number 7 is Ca2 plus release channels in Ca2 plus active transport pumps use ATP to restore low level of calcium ions in the sarcoplasm. The number 8 stage is tryptomyosin complex slide back into position where it blocks the myosin binding sites and actin. And then question number 6 is draw a table describing the location, appearance, and control type of each type of muscle tissue. So here's my table, my appearance column, skeletal, cardiac, and smooth muscles, my locations, and my controls. So my appearance for skeletal muscle is, it appears to be striated, non-nucleated fibers are parallel. My cardiac is striated, one central nucleus, and my smooth is no striations, one central nucleus. My locations for skeletal are in the skeleton. My location for cardiac muscles are in the heart, and my location for smooth muscles is GI tract, uterus, eyes, blood vessels. And then my control for skeletal is voluntary. We control our skeletal movements. Cardiac is involuntary. We don't control how our heart pumps. And then smooth muscles is also involuntary. We don't control how our tummy or our GI tract functions and moves involuntary. We don't control our eye muscles or our uterine muscles or our blood vessels. It's all something our body does for us. That's it.